So SDS Bionic has a whole host of amazing industrial coatings. The industrial sector is really important. That's our infrastructure. This is important to keep up, like our power grid and so forth. We're constantly fighting corrosion. What I want to go into a little bit today is a little more of the technology. How does this really work? You know, why is a clear coating with SDS Bionic different than a clear coating by any other person? Again, we're molecular based. We take inorganic natural quartz and we apply it to the surface. And because we use nano-sized quartz, nano is just a size, it's 1/1000th of a meter. So typical coatings that are in the market in the industrial sector have very large solids. Ours are very, very tiny. What's that mean? Large solids would be, for example, if I was to coat this piece of metal, would be like me putting large dinner plates on here. Everywhere where I put them down is a void in the middle, a big gap. Ours would be like putting a layer of beach sand. The way to prove this to you is I have a permanent marker. The permanent marker is a very, very, very thin stain. And what the stain does is it bleeds through the holes. This is powder coating. Powder coating is one of the industry standards. That's the current market. Now we're going a step beyond, more than a step. We're going many steps beyond. So when you look at a powder coated surface, it fades and oxidizes in the sun. If in fact it were to get breached, you couldn't re-powder coat it in the field. You're done. It has to be done in a plating facility. Ours is unique that you could apply it in the field, no special equipment. So the powder coating that we're looking at looks good and solid, like nothing is going to get through it. Moisture, corrosion, dirt, grease, chemicals. But I simply take a permanent marker. This side has our coating, this side doesn't. If I draw a line through there, okay, what's happening right now is that the permanent marker is bleeding through those holes and getting to the substrate. On the side with our coating, because we have such a tight matrix, again, no holes in ours, big holes in here, no holes in here, the permanent marker is actually just sitting on top. It couldn't leach through because there is no holes for it to leach through. It's sitting on top. How do I prove that to you? I simply take a sponge with a little bit of water. I'm not using a chemical or a solvent, it's just water. Okay. I'm barely going to scrub this. It'll be almost like an eraser board. So I take this side and just merely wipe it off. This side here, no matter how hard and how long I scrub, I could get a little bit of the surface portion off, but the rest is bled through all those holes. Any product, substrate, stainless steel, galvanized, aluminum, they all corrode, okay? What this does is no moisture can get through it. This is a piece of stainless steel. This half is treated, this half isn't. When you handle this piece with your fingers, you see how the stains get through on this side, how bad this side looks compared to this? Because stainless steel is also very porous. Okay? So this looks much better, it's much more durable, easier to clean because the grease and so forth can't get through this and bleed in like it did on this side. Galvanized, very common, especially in our electrical grid, light poles, that's the type of thing. The problem with galvanized, in the marketplace it was the best coating to date. Now we have this new technology, this revolutionary new technology. This lower half has been treated over the galvanized with our metal coat. This upper half is standard galvanized. This deposit on here is white rust. It starts to develop white rust. This is a sacrificial coating. It's an anode, it's zinc. Once this goes away, you can't reapply it. If this ever gets damaged, it can be reapplied. So this developed white rust. If you were to do this in a corrosion chamber, salt fog corrosion in UV, you would develop white rust on the untreated galvanized in 26 hours. The coated side doesn't develop any white rust for 864 hours. So from 26 hours of seeing white rust to 864 hours. 864 hours in a salt fog chamber test is almost 9 years time. Every 100 hours of testing equals a year. So we ran this for 1,000 hours. No red rust. We ran it for 1,200 hours, 12 years, no red rust. The untreated side, we developed the white rust in 26 hours. We developed red rust in 136 hours. Okay. The power grid, if it rusts through and one power pole comes down, it can create that domino effect. This is to preserve the necessity of electricity that we all rely on today. So again, this is one of the most important asset protection products on our industrial side of our coatings. Aluminum, very good metal, very efficient. Big problem is it corrodes very easily. It's a soft metal, okay? By putting the coating over it, we make it, again, a superstructure. It's quartz. If you can envision a quartz rock in the middle of the desert, nothing ever happens to it. The sunlight doesn't hurt it. The rain, storms, heat, cold, nothing. Same thing. Now we're just taking that quartz, we're turning it into a liquid form and distributing it through and on top of every substrate. Now it's like putting a rock on something. It won't burn. It won't break down in the sunlight. You can damage it by hitting it with a hammer, because you can damage a rock in the desert with a hammer, right? But again, look how good it looks. If you can see here, all the fingerprints and everything on this side of the untreated, and how nice it looks on this side. But now we won't corrode anymore.